In this video, we're going to prove that 1 is greater than 0 using some basic facts about the integers. So actually, we're going to prove three propositions here. The first one is that we're going to prove multiplication by negative numbers reverses inequalities. And that's really the main result of this lecture. The next two propositions, that the square of any non-zero integer is positive and that 1 is greater than 0, both follow from the first. So our proofs will use the following basic facts about the integers. We'll use trichotomy of the ordering on the integers. Remember, that's one of our axioms for z. We'll use that addition and multiplication by positive numbers preserves order. And we'll use a result about additive inverses, that the additive inverse of the product of two integers n and m can be written as the additive inverse of one of those integers times the other one. So let's get on to proving our first theorem. So if we have three integers, k, n, and m, with n less than m and k less than 0, then multiplication by k reverses the inequality. So k times n will be larger than k times m. So let's assume k, n, and m are indeed integers. And let's assume n is less than m. And also let's assume that k is less than 0. Now k less than 0 doesn't help us. We don't really have any results about multiplying by negative numbers. That's what we're trying to prove here. But we know that minus k is positive. We know that because if we add minus k to both sides of the inequality k less than 0, we'll get 0 on the left-hand side of that inequality, and we'll get minus k on the right-hand side. So minus k is greater than 0. In other words, minus k is a positive number. So we can multiply by positive numbers in the integers, and that will preserve the order. So we'll multiply the inequality n less than m by the positive number minus k, and we'll get that minus k times n is less than minus k times m. All right. So now we use our fact about additive inverses. We can rewrite minus k times n as the additive inverse of k times n, so minus k times n. And similarly with minus k times m. So we can express that inequality finally as the additive inverse of kn is less than the additive inverse of km. And then we're going to use that inequality by adding k times n plus k times m to both sides of this. So if we do that, we get k times n plus k times m minus k times n, or plus the additive inverse of k times n, is less than kn plus km plus the additive inverse of km. So you can probably guess what's going to happen here. On the left, the additive inverse of kn is going to cancel with kn to give us 0. The additive inverse of km added to km is going to give us 0. Okay, so we'll regroup those together using associativity and commutativity of addition. Then we'll add the additive inverse of kn to kn and the additive inverse of km to km. So we get that 0 plus km is less than kn plus 0. And of course that implies that k times m is less than k times n. And that's what we wanted to prove. We started with the inequality that n was less than m, and we've now proven that k times m is less than k times n. Okay, so now as a corollary to this, we're going to prove that if you have a non-zero integer n, then its square is greater than 0. So let n be an integer and not equal to 0. Now by trichotomy, we know since it's not equal to 0, it's either greater than 0 or less than 0. So we'll consider each case separately. In the first case, we assume n is greater than 0. Well, of course, if n is greater than 0, we can multiply that very inequality by n. And we get n times n is greater than n times 0, which of course gives us that n squared is greater than 0. Now in our second case, we have n is less than 0, and we're going to apply the last theorem that we proved, that multiplication by negative numbers reverses the inequality. So we can multiply both sides of this inequality by n, and we get n times n is greater than n times 0. In other words, n squared is greater than 0. All right? So in either case, we have n squared is greater than 0, and that proves the corollary that if n is a non-zero integer, then its square is greater than 0. So finally, we come to the title theorem of the video. In the integers, 1 is greater than 0. All right? And it's an easy corollary of the last corollary. 1 squared is equal to 1, and 1 is not greater than 0. So we know it's an integer, a non-zero integer, and so we know its square is greater than 0. In other words, 1 squared is greater than 0, and 1 squared equals 1, so 1 is greater than 0. And that concludes this video. Thanks for listening.